Dear students, welcome to the video differentiation. Differentiation of power functions. We have learned that differentiation actually gives you the gradient of the tangent to the curve at a given point. Now, given that y is equal to f of x, differentiation of this function is denoted by dy with respect to x or y prime. These are the two notations I use in order to show differentiation of a function. Now, after using the definition of differentiation, which is actually the result of a limit, we obtain this formula for power functions, given that y is equal to x to the power of n. Then y prime or dy dx, you may use one of these two notations, will be equal to. Now, to differentiate this function, I told you this formula is obtained by using the definition of the differentiation for different functions. Now, power is multiplied n, then 1 is subtracted from the power n, x to the power of n minus 1. So you can easily memorize this actually formula. So to differentiate x to the power of n, you multiply by the power, then 1 is subtracted from the power. Now let's see some examples. Example 1, find the derivative of the following functions: a x to the power of 7, b 1 over x squared, c root x, and dy is equal to constant number 2. For the first part, now I use this notation y prime. We learned that the function is multiplied by the power, so 7, then 1 is subtracted from the power, so 7 minus 1 will be 7, x to the power of 6. Now part B. First I write in this form. I bring x squared up to write in the form x to the power of negative 2. Then we can use easily the formula of x to the power of n. Now then differentiation will be equal to, is multiplied by the power, then 1 is subtracted from the power, so negative 2 x to the power of negative 3. You can rewrite it as a positive index, so I transfer it to denominator again, so it will be negative 2 over x cubed. Part C, y is equal to root x. I rewrite it as an index x to the power of half. Then differentiation will be, it is multiplied by the power, then 1 is subtracted from the power, so it would be half x to the power of negative half. So I will transfer to denominator, it will be x to the power of positive half, or x to the power of half will be root x, so it is the differentiation. And part D, y is equal to 2. Y is equal to 2, actually the power of x is 0, because x to the power of 0 is 1. 2 is actually x to the power of 0. Now differentiation will be 2, then it is multiplied by the power, so let me multiply by the power, then 2x to the power of 0 minus 1. So no matter how much it is multiplied by 0, so it will be giving you 0, so y prime will be 0. Now it makes sense. Why? Because I told you differentiation actually is giving you the gradient of the tangent to the function. Y is equal to 2 is a horizontal line, and the gradient of the horizontal line is 0. That's why the gradient of constant functions will be 0, as they are completely horizontal and having gradient of 0. Example 2, find the gradient of the tangent to the curve y is equal to x brackets 2x minus 1 times x plus 3 at the point 1 and 4. Now we already know that gradient of the tangent to the curve is obtained by differentiation, so we should find derivative function. I first expand x times 2x minus 1 times x plus 3 then it will be 2x cubed plus 5x squared minus 3x. First you multiply these two, x by 2x and negative 1, it will be 2x squared minus x, then multiplying by x plus 3. At the end it will give you this expression. Now, in order to find gradient, we need to differentiate. So you can use this notation, dy dx or y prime, doesn't make any difference. So power is multiplied, so it will be 3. Then 1 is subtracted from the power, so 3 times 2x squared plus 2. So this function is multiplied by the power, which is 2. Then 1 is subtracted from the power, so it will be 1 minus power of x is 1, so it is multiplied by 1. Then 1 minus 1. So dy dx will simplify to 6x squared plus 10x minus x to the power of 1 minus 1, which is 0. X to the power of 0 will be 1, so it will be minus 3. And do you remember in coordinate geometry you have learned that the gradient of mx plus c, y is equal to mx plus c, was m. So it is minus 3x plus, for example, a constant c. So the gradient of this function is negative 3. Now you can interpret that point that you have learned in coordinate geometry, that gradient of y is equal to mx plus c is m. Now you have the gradient formula. It is asking you to find the gradient at this specific point for which x is 1. So replace it in the equation to find gradient. Be careful, it should be replaced in differentiation, derivative function. So it will be 6, 1 to the power of 2, 10 times 1 minus 3, which is 16 minus 3, giving you an answer of 13. It is the gradient of this function at the point 1 and 4. Example 3, the curve y is equal to ax to the power of 4 plus bx squared plus x has gradient 3 when x is 1 and gradient negative 51 when x is negative 2. Find the values of a and b. First, we know that as it says gradient, so gradient formula is obtained by differentiation. So I differentiate dy dx or y prime will be equal to, it is multiplied by the power, which is 4. Then 1 is subtracted from the power. So next one, 2bx to the power of 1. And differentiation of x will be 1. Now, it says the gradient is 3 when x is 1. So when x is 1, the differentiation will be 3. So 4a, when 1 is replaced, it will be 2b. 1 plus 1 is equal to 3. When x is negative 2, I replace it, 4a. Negative 2 to the power of 3 plus 2b plus 1 is equal to negative 51. If you simplify, the first one will be 4a plus 2b is equal to 2, and the second one will be negative 32a minus 4b is equal to negative 52. The first one can be multiplied by 2 to have the same coefficient for b to get rid of b. As you see, you have a pair of simultaneous equations. So I multiply the first one by 2. It would be 8a plus 4b is equal to 4, and negative 32a negative 4b is equal to negative 52. Now if you add these two equations, they cancel out each other, so it will be negative 24a is equal to negative 48, giving you an answer of 2 for a. So if a is 2, if you replace in one of the equations, so plus 2b is 2, 2b will be equal to negative 6, then b will be negative 3 at the end. So a is 2 and b is negative 3.